My name is Amanda Golbus, and my affiliation is the Southern African Large Telescope, which is actually based in South Africa, and I'm stationed in Cape Town. And I'm not officially a part of the New Horizons team, but I've been studying Pluto for many years, particularly using stellar occultation techniques. So a stellar occultation is just kind of a fancy phrase for when a star, the stellar object, passes behind the planet as seen from here on Earth. So you, behind the camera right now, you can imagine that this is Pluto and this is a distant star. And as you watch, if Pluto moves in front, I can't quite tell the alignment, which kind of illustrates how difficult this is. If you see Pluto moving just in front of this tiny star and then moving past, you on Earth have to be right in the location of that shadow path to see the starlight be bright, and then it would go away, and then it would come back. But we have to predict exactly when Pluto will be exactly in front of this star, and then the exact location on the Earth. Those of us that do it kind of have this idea that we're like astronomical cowboys, because we end up kind of running all over the globe. I've been to Australia, and to Chile, and to Hawaii, and to Namibia, and in Namibia in particular, that one was fun because we didn't have a telescope that would be in the path. So we took a 12-inch portable telescope and we rented a generator and we just drove off into the bush. And we're kind of watching over our shoulders the whole time for baboons and lions and all kinds of crazy things. But we ended up being in the shadow path and actually getting data. So it really puts a new twist on astronomy. One of the most fundamental properties of Pluto that we still don't know is how big it is. And all of these observations we've made and all of the data we've taken, we still don't know the fundamental size. So I'm really interested to see that. I also think there have been some fascinating features in the occultation light curves that have suggested that there could be some type of a haze, but we don't always see it. And so I'm really fascinated to find out if there's something like cryovolcanism or some other type of active process that could be causing features in the atmosphere. Because Pluto is so cold and so far away that you just don't really expect it to be that active. I think it's always interesting to people when we reach the outer limits. And in this case, for decades and decades, Pluto was the last edge of the solar system. It was the farthest body that we could study. So there's always this kind of human curiosity about what's out there and what's beyond that, and trying to explore even further. And astronomy, of course, is a great topic for that type of thing. I'm Amanda Golbus, and I love Pluto because it is an object that is far out in the solar system, and yet we can still learn a lot about it by studying it.